So let's take a look at some of what we're going to cover this semester, just real quick over the next 1 or 2 weeks, and I'll keep referring back to this document as we continue. We're going to start with this is just a breakdown of what we're going to be covering and roughly how they're all interrelated. So first thing we're going to talk about are the different types of bonding models. We spent a lot of time talking about ionic bonding last semester, so we're going to start up again this semester talking about covalent bonding, looking at how electrons are shared. Ionic bonding deals a lot more with thermodynamics side of everything, but covalent bonding focuses pretty heavily on the ideas of the electronic structure of atoms and how that interrelates to the molecules. We will be talking about covalent bonding, and covalent bonding takes two basic forms: valence bonding theory and molecular orbital theory. This is all out of chapter 9 and chapter 10, and so that's a good place to be spending your time over the next couple days. Valence bonding theory is where we're going to start. Valence bonding deals a lot with looking at the Lewis dot structures of the molecules. We can make a large number of simple assumptions and assertions and glean a little bit of information from the Lewis dot structure. So one of the things we're going to review is how to draw correct Lewis dot structures. You really need you need to have the Lewis dot structure first before you can do any of this other stuff. From the Lewis dot structure, that will directly or indirectly tell us the shape of the molecule and the hybridization of the atoms. All of that information is all contained within the Lewis dot structure, and hopefully by the end of this you'll be able to extract that information. But it also works the other way. The hybridization is also directly related to the shape, and so you should be able to predict bond angles and shapes of molecules from that. With the shape, we rely on things like valence shell electron pair repulsion concepts to determine the shape, though you can also sort of memorize a little bit of a schematic for working through those. And the shape directly ties into, like I said, the hybridization. Valence shell electron pair repulsion, pretty good, pretty simple idea for describing why molecules are shaped why they are. And for us, it's really important because it tells us about the polarity and the physical properties of the molecule. So you can use it to actually predict things like boiling points and melting points of molecules. Jump into molecular orbital theory, looking at molecular orbitals and how molecular orbital theory is different from valence bond theory. Valence bond theory and molecular orbital theories are different bonding models. They are often used to tell us the same information, but molecular orbital theory is actually a little more complete, though much more difficult for larger molecules. And with molecular orbitals versus atomic orbitals, we're going to look at how they're similar and how they're different. And we're going to look into the concepts of bonding versus anti-bonding molecular orbitals, sigma versus pi orbitals, and this idea of bond order, which we also have a tendency to think of as the number of bonds. So that's the overview, and then we're going to pick that up, and from there we're going to go on to kinetics.